Maybe you've heard people talking about the energy of the future, or the energy which will save humanity. They were talking about nuclear fusion.
Is it true that this energy is one of the best candidates to be one of our main energy sources in the future?
Whether it is or not, join us in this introductory video on nuclear fusion.
The process of nuclear fusion consists, as its own name says, on the fusion of the nuclei of two light atoms. This process releases a huge amount of energy, but we are sure that you don't realize how much energy it releases. Later, you'll see.
Seems like easy, right? Yeah, that's all. Thanks for watching and see you in the next video. Wait. It's not that easy. If it's such a simple task, why don't we have this energy yet? Well, we don't have it because it cannot be so easily done. So let's see why.
As we have mentioned previously, this process involves the union of two atomic nuclei, both positively charged. Then, when we have to join them, both nuclei repulse each other. So we have to invest a huge amount of energy in order to obtain the release of energy and the fusion of the two nuclei. And the problem starts here. The amount of energy invested is higher than the amount of the energy obtained, so it isn't profitable to carry out nuclear fusion.
Moreover, once the reaction occurs, a huge amount of energy is released, and the problem is how to control and keep this energy, because otherwise it can cause really serious damages, such as an enormous explosion which would cost thousands of lives.
Even with these difficulties, fusion has lots of positive aspects, and that's what we are trying to obtain. The reaction doesn't produce any greenhouse gases at all, so it doesn't produce as much as other energy sources do. Furthermore, it uses deuterium from seawater, a clean and abundant energy source.
However, this process doesn't work yet, and has several bugs, such as the high temperature that we have to reach in order to recreate the necessary conditions. But now, what if I told you that thanks to constant fusion reactions we are still alive, but these reactions don't occur on Earth, they occur in the Sun? Yes, it is. The Sun, in order to send heat, performs nuclear fusion reactions.
I know that you'll be asking yourselves, how's this possible? Well, in the center of the Sun there are huge quantities of hydrogen atoms, which move at really high speed due to the high temperatures, and sometimes these atoms collapse and fuse together into helium atoms. But the important fact is that when they fuse, they lose a little bit of this mass, which is later converted in energy and released by the Sun. Then the helium atoms fuse together into carbon atoms, and it occurs the same as in the previous fusion process.
In the Sun, the process of fusion stops here. However, in other big stars, this process continues with the fusion of helium and carbon leading to oxygen, and finally oxygen and helium fusing into neon. And this is how every star, using fusion, generates its energy. And now, here comes the data. Every second of every day, around 5 million of mass released from the fusion reactions converts into energy.
We cannot leave this video without talking about ITER. It is an international project with the aim of proving that humanity is capable of performing nuclear fusion. It is one of the most expensive projects in science, similar to the Apollo project in 1969. In the core of the ITER, there's a huge machine called tokamak.
Inside this giant device, isotopes of hydrogen, deuterium and tritium will fuse together thanks to the high temperatures, which will be recreated inside, as well as the gravitational force, equivalent to the Sun's one, thanks to magnetic fields.
So well, unluckily we're coming to an end. In this video we have been introducing nuclear fusion, but now is your turn.
Do you think that humanity will be able to perform nuclear fusion successfully?